Hey everyone, so this is the agenda for the week of 4/20. Similar announcements to last week. Assignments should be finished by Friday. Tutorials are going to be 10 to 11 a.m. Monday through Friday through the Zoom link in the announcements. And I need you guys to pay attention to those announcements just in case there are any changes. This week you will be responsible for vector quizzes, which is an online application to go over the stuff we covered last week. There are 3 videos you guys need to go through, and you're going to create your own real-world problem and solve it. So what you're going to do is you're going to choose a place that you're really excited to go to once this quarantine is lifted, and then you're going to look at the directions on a map application, or you can do it on a real map if you have one available to you. And I want you to create the vectors that would be the straight lines, and then the turns will give you another vector. And so I recommend choosing somewhere close, and there needs to be at least 3 vectors, and all of these instructions are in the assignment for this week. So let's get started. Okay, so here is a really simple example problem of how vector addition can happen in directions. So I did not choose a place in my neighborhood or draw a map, but I wanted to give you a simple example to base your maps off of. So, if a car moves 12 miles north, starting here, 19 miles east, and then 12 miles south, what is the displacement? So note that all of my units are actually 2 instead of 1 to save space. And also I included a theta or an angle. And so I noticed in a lot of responses that the theta was a little difficult because the tail end of the vector was in different places. And so I just wanted to clarify that here the theta is 90 because if there was an x and a y axis drawn, the degree would be 90 to the left. And then here from the tail, once again, there was a y and an x-axis, it would be 0 degrees because it starts here and ends here, the amount going counterclockwise degree-wise. And then here, starting at the tail, and if there was an x and a y-axis, the degree would be all the way to 270 going counterclockwise. And then this is the resultant vector, or from beginning to end. And so you'll see that the x component is 19 and the y is 0. And so my solution is that from beginning to end, I am displaced 19 miles east. So notice that 19 is my magnitude and east is my direction. Or we have theta as 0 right here. So this I all want you to include in your map. And so I also wanted to talk about a few other things. I wanted to talk about a couple of other things that I think are really cool. So 2 vectors can be orthogonal or perpendicular if the angle between them vectors is 90 degrees. So I'm going to use v and u in our example, and you'll notice that they're perpendicular, or the difference between the angles is 90 degrees. But we can do that algebraically by figuring out the dot product. So the dot product is not multiplication of vectors, it's something different. So what you do is, if we're taking vector v and doing the dot product with vector u, then we take the first term of the first vector and multiply it by the first term of the second vector, which is right here, and then we add the second term of the first vector times the second term of the second vector, which gives us 0 plus 0, which is 0. So they are orthogonal. Also, if you wanted a more general form, vectors don't just have to be x and y. We can also talk about xyz, xyzw, all of these further things in mathematics. And so generally we write it as like a1, a2, ... a3, because there can be as many more. I apologize, this is supposed to be an n, and I'm going to call this one m, because 3 would be in here and here. So that means these have to be n's as well. My mistake. And so what you would do generally is you'd multiply the first term in the first vector times the first term in the second vector, and then add the second term times the second term, and then add the third, fourth, fifth, whatever, all the way up to the nth term, so times the mth term, which is an times bm. And last thing I wanted to talk about is that we are now dealing with vectors in component form, but we can take a two-dimensional vector, which means it has an x and a y, or it only has like a two-dimensional plane, like this piece of paper, and we can put it into a matrix. And so a and b can also be swapped with x and y. I just chose arbitrary letters. And so these two are equivalent, but I like to write them this way for algebra. And so if we took the dot product of the same vectors v and u, this is the first term, and this is the first term. So you multiply the first term of the first vector times the first term of the second vector. And then similarly, we add the second term of the first vector times the second term of the second vector. And then we get 0. So we know that these two are also perpendicular or orthogonal.